let's get started. I'd like to introduce KYZEN's own Will Sweet.
Thanks, William. And thank you, everyone, for attending. Good evening or good morning, depending on where you are in the world, for what will be a short talk on the benefits of passivation on stainless steel. I actually gave a more in-depth talk on the actual act of passivating stainless steel this past September. If you want to go back to our website and look at the older tech to techs from September, you can find that. Today, we're going to focus mainly on the actual benefits. I will do a short review to start off with, so that everyone's on the same page, anybody that may not have seen that last tech to tech, on what passivation actually involves. You're going to be spending the bulk of the presentation on the reasons why you might want to do that for your stainless steel parts. And then finally, moving on to, do you need to passivate at all? So passivation. Stainless steel passivation is the chemical treatment of stainless steel with a mild oxidant. And in today's case, I'm going to be referring mostly to citric acid as that oxidant. And what this citric acid, this mild oxidant, is going to allow you to do is to form a protective passive layer on the surface of the part, of your stainless steel part. This can only happen when the surface is completely free of all contaminants. The definition of passivation, as well as actually removing the free iron from the surface. And in doing so, it allows a chromium oxide film to generate over the surface of the part. And that's what that protective passive layer is. It's that chromium oxide film. So yes, you want to remove all contaminants like the free iron. You also want to remove any pre-existing oxide or rust. I kind of harp on that in the last presentation as well, because if there is rust, even if there's rust underneath this protective passive film, it's still going to continue to grow underneath that protective passive film, kind of defeating the purpose. This is a general process overview of what a passivation line could look like. The pre-clean step on the left, that could be done with a vacuum degreaser, an alkaline aqueous wash, or a vapor degreaser, however you're going to remove all of the particulates and the different things from the surface of the metal. Then moving on to the right side of the chart, this is the actual passivation line. The first tank you see, the passivation tank, typically, I think more often than not, you're going to see this in immersion tank-to-tank systems, but it can be done in spray, and I've seen it done very effectively with spray machines as well. And then followed, after the passivation tank, it's followed by 2 rinses. Again, this is just an example. Some people only use 1 rinse. We think more rinses is better than less rinses. You're only going to be as clean as your last rinse. So that's kind of why we have that made up here. It is also important to note that as soon as the part is rinsed, after it is passivated, the active passivation stops. So however long, say you have a 5-minute wash cycle time in the passivation tank, in those 5 minutes, those are the only 5 minutes that the surface of the metal is going to be passivating. These are some average operating parameters. Again, it's going to differ based on your process, your part geometry, your part size, the size of your tank, what have you. There's a lot of different variables to consider, but typically, you can get well passivated parts in 5 minutes or so, temperature between 140 and 160 F. A concentration of, in this case, a citric acid chemistry at 50% concentration. Note that all of the citric acid products that you're going to be using, depending on whatever chemical provider you are involved with, is not going to be 100% citric acid. So that 50%, it could be it's a much lower concentration of actual citric acid content. Just remember that. And then any kind of impingement is just going to help speed up the process, whether that's turbulation or ultrasonics. Both of them work very well. Moving on to the benefits of stainless steel passivation. So first and foremost, it's corrosion resistance. That's the main reason that you want to passivate your stainless steel parts. But then you ask, isn't stainless steel supposed to be corrosion resistant anyways? Yes, it is. It's also dependent on the different grade of stainless steel, like 100, 200, it goes up to series 400. But the answer to that question is yes. Most grades of stainless steel are already pretty resistant to corrosion, but in some cases, resistant isn't enough. You need it to be corrosion proof, say for knee replacements, any kind of metal that's going to be put into a human body for a long period of time, it can't rust, or that's going to cause issues inside of a human body, as you might imagine. So that's where passivation comes into play here. So in the medical field, in the aerospace field as well, there's a lot of metal parts, stainless steel parts in airplanes that can't rust, or you might have planes starting to fall out of the sky. And a little less drastic measure when it comes to brewing. So making beer, you have to passivate the tanks that the beer is being brewed in, and that's so you don't get rust in the beer. I wouldn't imagine that drinking a little rust is really going to harm someone permanently, but there could be lawsuits involved, especially if you have a larger brewery like that. Also, quality assurance. So, I mean, this depends on what type of quality standards your customers require, or how much money they would spend to increase the amount of quality that they get from their parts. But passivating stainless steel is going to allow you to demonstrate quality assurance and have a more consistently high quality product. This is because of potential product contamination. The iron that I mentioned earlier in this presentation that passivation removes off the surface, iron itself is very chemically reactive. So it can react with many different types of soils, whether it's dust, dirt, grime, later on down in the process, they can cause issues. So removing that iron is going to help the part stay cleaner longer. Citric acid solutions also tend to bond really well with other contaminants. So this dirt, grime, whatever the parts might run into down the line, it can bond with the citric acid and it can be rinsed off much easier in the rinse and other stages of the wash as well. And finally, aesthetics. So customers love bright, shiny parts. We all know that. And these citric acid products, they tend to be great cleaners and great polishers as well. That's for the stainless steel like we've been talking about tonight, but also for yellow metals like brass and copper. I've seen some really nice citric acid products that are probably the top-notch brass brighteners out there. And actually, if you want to go deeper into this topic, Jason Schwartz gave a presentation this past July on just brightening yellow metals, and I know for a fact that he mentions citric acid products there as well, if you want a little bit more information about this topic. And lastly, do you need to passivate? So what I have listed here is an ASTM spec, the ASTM A967. And if you should know if your customer is requiring you to have an ASTM spec, and if this is the spec that you have to abide by, you do have to passivate, and these are the parameters that you have to run in your passivation line. So in the passivation tank, in the top in the citric acid column, it calls for between 4 and 10% citric acid content in the passivation tank. And like I mentioned, citric acid products aren't going to be 100% citric acid. There's going to be builders, inhibitors, silicates, several different types of chemistries in there so that it can do more than just passivate. It can clean the part, and it makes it a better whole product. So the reason I'm saying this is because your chemical provider knows that. They also have this spec in mind. So when I mentioned 50% earlier, 50% of most citric acid products will probably get you between 4 and 10% citric acid content as a whole. And then as you move right across the table, similar fashion. So you're going to have to be in between 60 and 71 degrees C and run for at least 4 minutes in that passivation tank to be within spec. And then I've talked almost exclusively about citric acid tonight, but you can also passivate with nitric acid. If you notice at the bottom, you are going to need a little bit more acid content as a whole. You have to have at least 20% in all of these different types of scenarios to meet this spec. Also note that the time is also increased quite a bit. You're going to have at least 20 minutes in the nitric acid passivation tank to make sure that you are in compliance with this ASTM A967 spec. And how clean is clean? So, I mean, again, if you need to know if you need to passivate or not, it goes back to customer specifications, whether or not they have to meet that ASTM spec. This ASTM, the compliance in this spec is probably the first question you should ask them. But also issues down the line. So if you're noticing after you've cleaned the parts, you've treated them, passed them down back to your customer, shipped them back to them, if they're corroding down the line, or if they're running into cleanliness issues down the line, maybe dulling, something like that. A way that you could increase the quality assurance of the products is by actually passivating. What maybe the parts were corrosion resistant to start off with, but you can actually corrosion proof them with passivation, improve the cleanliness with using a citric acid product, and what have you. So I believe that's all the time I have today, and I welcome any questions that you guys might have.
All right, thanks, Will. If you would like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@KYZEN.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, have a great day.